Okay. We did plotting of graphs, and I think we were doing inequalities and shading. Yeah. Did you get time to practice the remaining questions?
Yes, sir, I did them.
Any confusion, anything you would like to discuss?
No, sir.
Okay. And what about these questions? 10 to 27.
Yes, I did them till number 16,
Okay.
but I understood them, so we can go.
Okay. Okay. The next topic is distance time graphs, also known as travel graphs, also known as kinematics. So when a distance time graph is drawn, the gradient of the graph gives the speed. We will be looking at distance time, velocity time, and acceleration time graphs. Gradient of distance time graph is giving me speed. In case you ever forget that, which you shouldn't, with practice you'll be able to learn them by heart. So basically, gradient will give us y over x. So gradient is change in y over change in x. So for now, we have distance on y-axis and time on x-axis. And we know distance is equals to speed into time. So see, distance divided by time is actually speed. That is why gradient is giving us speed. So from O to A, if you see this is a straight line, that is fixed gradient, constant gradient. So that means constant speed. A to B, see the gradient is decreasing. Hence, the speed is decreasing and the gradient decreases to zero. It eventually becomes horizontal at B. So the speed is decreasing to zero. B to C, the gradient is zero. That means the speed is zero and it means the object is at rest. It is not moving. C to D, it accelerates. From C to D, if I talk about the gradient, see the gradient is increasing. That means the speed is increasing and hence it is accelerating. D to E is again a straight line, constant speed. And when it is not as fast as O to A, that means if we would just compare these two, gradient of OA is more than gradient of DE. OA is more steeper as compared to DE. You can also estimate the speed of any point by drawing a tangent at the point and estimate the gradient of the tangent. For example, the graph shows the first 500 meters of car journey. Estimate the speed at which the car was traveling after 4 seconds. So 4 seconds, at 4 seconds, we just draw the tangent and we will find the gradient of this tangent. Use any two good points. I find this one. This is 6.5 and y is 400. 6.5, 400. And another point, this one, 1.5 and 200. So y2 minus y1 over x2 minus x1. 200 over 5 is 40 meters per second. Practice exercise. Eventually in exam, you will face these questions. You will face a mixture of these: distance, speed, and acceleration. After we are done with distance time, when we will move on to velocity time, it would include both distance and acceleration. So for now, distance time graph is definitely giving us distance and the gradient is giving us the speed. Question 1. The graph shows the journey made by a van and car starting at Baden, traveling to St. Gallen, and returning to Baden. So this is B, this is G, and again back. For how long was the van stationary? The stationary means not moving. For how long was the van stationary? I can see there are two sections which are horizontal, 1 and 2. And on the x-axis there is time. So first we just figure out that we have 4 boxes in 1 hour. That means one box is 60 divided by 4 equals 15 minutes. So 2 boxes, and then third. So 15 into 3, it was stationary for 45 minutes. B part says, at what time did the car first overtake the van? So the car overtakes the van where it crosses it, and the distance of car is now becoming more than that. So it overtakes at 9:15. C part says, at what speed the van traveling between 9:30 and 10? So this is 9:30, this is 10. Between these 2 points, we're talking about this region. So it is not necessary that we stay in this region, because this straight line, complete straight line, would have same gradient. We can choose any 2 points. So for now, I'm taking this is 70, this is 40. So rise is 30 divided by, this is 9:30 to 10, that is half hour, 0.5. So this is 60 kilometers per hour. Gradient is 60 kilometer per hour. D part. What was the greatest speed attained by car during the entire journey? Now we need to see which side is steepest. So see if this is definitely not. We can see this is less steep. So either section, first section or last section. Now you need to see which one is steepest. And when I'm looking at this box, in one horizontal box, it raises by 2. And when we come here in one horizontal box, this is more than 2. It is more steep. So at the last section, car is traveling at greatest speed. So we would find the gradient of this section. So let me use this point. This is 100 kilometers and divided by 1, 2, 3, 4 boxes. So basically 100 kilometers per hour. E part. What was the average speed of the car over its entire journey? Average speed is total distance divided by total time. Can you tell me what is the total distance traveled by car?
Sorry, total distance. So it will be from 0 to 40, and then from 40 to 100. So 0, 40 plus
So in that
140.
case, go from 0 to 100 directly.
Yes, sir. 100 and then till 0. So 200?
200, that's right. So
Mm.
total distance is 200, and total time, the car starts at 8:45 and ends at
Yes,
12:15.
sir. Yes,
So
sir.
1, 2, 3 complete hours and 15, 15 half hour.
Yes, sir.
3.5 hours. Total distance, I'm using calculator. Total distance over total time, I'm getting 57.14 kilometers per hour. Okay. The graph on next page shows the journey of a bus and car along the same road in Bulgaria. The bus goes from Sofia to Rila and back to Sofia. The car goes from Rila to Sofia and back to Rila. So this is Rila and this is Sofia. Car is in solid line, bus is in dotted line. Okay, try these. parts. Try to answer them. What? When did the bus and the car meet for the second time? Is the graph readable?
Yes, sir. When it meet, sir, they meet first time and then the second time
Just make a
uh,
guess.
at 9. Yes, sir. So this will be 9, around 9:20 or something.
I would say 18. I'm
Yes,
guessing that this is actually the fifth part.
yes,
If
sir.
this is 15 minutes, I'm
Yes, sir.
dividing them into five equal parts.
Yes, sir.
So one part would be 3 minutes. 15 divided by 5 is 3. So 15 plus 3, let's make it 18.
Yes, sir.
9, 18. B part. At what speed did the car travel from Rila to Sofia? From Rila to Sofia. First, identify which section is this. You can
Mm,
uh, highlight it by telling the time. Between which times is this section? Rila to Sofia.
From Mila to Sophia. From Sophia. It will, we will take from 80 to 0 and time
Yes.
7:45.
This is 7:45
Yes, sir.
and
7:45.
start time is
Uh,
6:30.
6:30. Yes, sir.
So one, two, three, four. Four boxes is 1 hour, and there's one more box. May I say this is 1.25 hours,
Yes, sir. One.
and it is traveling 80 kilometers.
The one
Eighty one
box is
point two five.
the one box is 15 minutes. So won't it
15
be
minutes.
1.15?
Just see. When we talk about these four boxes, these are 60 minutes. It is 1 hour. 0.25 hours is 15 minutes. See, this is
Yes,
60
sir.
minutes. This is 15 minutes.
Yes,
Another
sir.
15, another 15, another 15. But what do we say for this? We do not write 1.3. We write 1.5, 1 hour,
Yes, sir.
point 5 half
Yes, sir.
hour. So
Yes.
that is 30 minutes. 15
Oh,
minutes is 0.25 hour. Basically, this is 1 by 4 of r is equal to 15 minutes. So 80 by 1.25 is 64 kilometers per hour. C part. What was the average speed of the bus over its entire journey? So bus is in dotted line. Average speed. Try this. Stuck somewhere? C part.
Yes, sir. 1 second. So we will do average speed, total distance is 80, 160.
Yeah, total distance is 80 and 80, 160. And what is the total time?
Time is from 6 to 10, 15. So 7, 8, 9,
What do we write in denominator?
4.25.
Correct. 4.25, and I'm getting 37.6 kilometers per hour. D part. Approximately how far apart were the bus and the car at 9:45? 9:45. How far apart are they? This is 9:45.
Uh, so can you repeat can you show me the question?
Yeah, yeah. Approximately how far were the bus and the car at 9:45? How far apart are they from each other?
At 9:45.
At
So
9:40.
at 9:45, 9, divided 40 kilometer.
Okay.
40 kilometer.
See, at 9:45, when we just keep on going up, I find this intersection, right? So this distance is between these two boxes. This is 25. So in between is 22.5. One number, 22.5. Then we keep on going, and this is actually not in the middle, right? Do you want me to zoom in? You see this?
Yes,
This
sir.
is the line at 9:45.
Yes,
So this
sir.
is not the middle. It is little below that. So I would say that this is 65 to 70. If I just say this is 1 and 2, so that should make it 67. So 1 is at 67 kilometers
Yes,
and
sir.
22. So
Yes,
67 minus 22.5 gives me 44.5. And definitely that's an approximation. One may get 45 or 43 or 42 will be acceptable. E part. What was the greatest speed attained by the car during its entire journey? Greatest speed by car. There are three sections. Just to communicate, I'm labeling them A, B, and C. Definitely the horizontal sections are zero speed. So for the car A, B, or C, which section shows the greatest speed? Share something. What are you calculating? How would you decide which part A, B, or C the car was at maximum speed?
Uh, so I was collecting the max. It will be think C. Wait, no, no B.
B, yes.
So,
So you can just see and decide quickly. See, this is one box and three boxes. One and three.
the slope. The slope is
And
in.
this is one and
Yes,
four.
yes, sir.
This is one and less than three.
Yes,
So
sir.
definitely B is the steepest.
Yes,
So it's
sir.
covering 20 kilometers if I just take these two in 15 minutes. So that's 20 kilometers in 0.25 hours, making it 80 kilometer per hour. Okay. Try question number three and try to do it with voice. Break the silence.
So after 10 seconds, so car B,
Correct.
and after 20 seconds is car A.
Correct.
B is in front, like how long is it in front?
No, just the time
Uh, So it's
and probably the earliest.
4,
You can just make a guess. This is the point of intersection.
7, or 8.
Eight. So 8 seconds, that is in front. And
Yes,
let's just do it the range. And
it
till
like 15, 18. Yes, sir.
when are B and C going at the same speed?
B and C.
This is critical. This is distance time graph. So look closely. When are B and C going at same speed?
So it will be at uh, B and C.
Yeah, C is the one which is actually a straight line, and B is the
Yes.
curve.
So it will be when they're going the same speed, when they both are like connecting.
No, when they are connecting or intersecting, that is the same distance.
Okay, okay. So like when they are at time 20.
At time 20, I don't think so. See, this is distance time graph. What is it that will give you the speed from this graph? What thing will give you the speed?
Distance over time. Speed.
Distance over time, yes, gradient. So what will we do when we are doing this on paper? We would try and draw a parallel line parallel to C where that line would be tangent to B. And one way of doing so is I will place a set square against C that would be much larger than this. You see this, and this is 90 degrees. I'll place a set square and then another set square this way.
Yes, sir.
Now let's say this is X and this is Y. I will slide Y upwards while it keep touching this. And at a certain point where it will be tangent, I will label that time when gradient of C and B is equal. So probably let me say 16.5 for now.
Yes, sir. For B and C.
B and C are moving at same speed at that time.
Yes, sir.
Which car is going fastest after 5 seconds?
Uh, Fastest of 5 seconds is 5 seconds. I think B, A, B. No.
Just change. You switch them. After 5 seconds, if I this is 5 seconds, and just after 5 seconds, I would look at the gradient. So B has the steepest gradient,
Yes, sir.
A is less steep, and C
Yes,
is in between.
yes, sir. B.
Which car starts slowly and then goes faster and faster?
A.
Correct. Because the gradient is increasing.
Yes, sir.
Estimate the speed of car A after 10 seconds. This is 10. This is the point.
A is distance is like,
No, speed. Speed is you get the speed by drawing a tangent.
yes, sir.
We'll find gradient of this tangent. Let's say one of the point is this, another is this. So we have like 50 to 350, that is 300 over 10, 15, 20, 22.5,
Yes, sir.
13.3. And what were the units? This is in meters per second. Okay. In questions 4, 5, and 6, draw travel graphs to illustrate the journey described. Draw axes with similar scales. To question 2. Okay. So similar to this, like 2 centimeters would represent 10 kilometers, and
Yes,
4 centimeters will represent 1 hour.
yes, sir.
2 and 4. 10 kilometers is 2 centimeters, and 1 hour is 4 centimeters. Okay, let's see. It says Mr. Shaw leaves home at 8 and arrives and drives at a speed of 50 kilometers per hour. After half hour, she reduces her speed to 40 kilometers per hour and continues at the speed until 9:30. She stops from 9:30 until 10 and then returns home at a speed of 60 kilometers per hour. Use your graph to find the approximate time at which she arrives. Okay, just consider these boxes. as 1 centimeter mark, and let's sketch this. Okay, it starts at 8. Let's say this is 8, and one, two, three, four boxes. This is 9, another 4, 10, another 4, 11. We'll just keep on adding them as required. 11. And on y-axis, this is 10, 20, 30, 40, 50, and so on. This is kilometers, and this is time, hours. See, Mrs. Young leaves at 8, drives at a speed of 50 kilometers per hour. So what I would do is 8 to 9 is 1 hour, and if in 1 hour they should cover 50 kilometers. I'm not drawing this line. This is just giving me the rate. I will place my ruler against these 2 points. But how long am I going to draw? It says after half hour she reduces the speed. So when I'm just drawing this line, I will stop at half hour. This is half hour, 8:30. And then I'll remove the scale. Or else I can also see that it is 50 kilometers per hour. So in half hour, it would be 25 kilometers. You can also mark the point at 25 and then draw. She reduces her speed to 40 kilometers per hour and continues until 9:30. So 40 kilometers an hour. Now she's already at 25. 25 plus 40 gives me 65. This is 60. This is 70, and we can see 65 in between. So 40 kilometers per hour. So this is 25 already at 8:30. So at 9:30, it should touch this 65-kilometer mark. Getting it? You don't need this red point.
Yes, sir.
Now we will join these two and draw the line till 9:30. And this is exactly 9:30. So 8:30 to 9:30. So we are going to draw it completely. This is the black line is actually less steep than the blue. Blue is covering 25 kilometers in half hour, and black is covering 20 kilometers in a half hour. Black is less steep, blue is more steep. Okay, then she stops from 9:30 until 10. So this is already 9:30, and she stops till 10, and then returns home at a speed of 60 kilometer per hour. This is already 10. So 10 to 11 is 1 hour, and she covers 60 kilometers. So this is 65-kilometer mark. 60 kilometers would make it till 5. This is that point. And we would join these points and extend the line. And the question says at approximate time at which she arrives. I can We can definitely calculate that as well, because she's covering 60 kilometers in 1 hour. So definitely remaining 5 kilometers, 60 kilometers in 1 hour. So 5 in x. So that is 5 over 60.
Yes, sir.
Or let me say 60 kilometers, 60 minutes. So 5 kilometer will be 5 minutes. So this is 1:11:05. And this is done. I'm going for question number 9, and the remaining questions definitely needs a graph page to practice. And please do not try that digitally. Solve them on paper.
Yes, sir.
Okay, question 9 says three friends Hana, Fatima, and Carrie took part in an egg and spoon race. The distance time graph for the race is shown here. Describe what happened in the race, giving as many details as possible. Okay, let me talk about Hana, and then you can talk about any other member. If I just see this is the path which Hana is taking, so as many details, I would slowly just draw the line and keep speaking. I would say that Hana started off at the greatest rate as compared to Fatima and Kerry. So she's increasing speed, and then at 2.5 seconds, she eventually decreases speed and stops for the next 10 seconds. Then she again picks up speed, accelerates for the next 3 seconds, and increases the speed, and then eventually again decreasing the speed as the gradient is zero at time 17.5 seconds. And you see this graph is actually going back, and after time, let's say 19 seconds, she is going backwards because the line is coming down. She's going backwards towards the starting point. Okay. Try explaining the graph for any other member. Choose one and explain.
So we can. So if I do the answer that is, so can we say that like Carrie was the slowest one to start,
Yeah, we can say that.
and
Least gradient.
yes, sir, and like her speed was slowly increasing,
Correct.
and then and she covered the most distance.
Correct. Yeah, we can also say that if we knew where the finish line was,
Yes, sir.
so she covered most of the distance. Yes.
Yes, sir.
Yeah, draw. We did four. Fifth says draw. Hmm. We need graph paper for all of these questions.
Yes, sir.
Okay, in similar manner, speed time graph. Homework will be for distance time, missing questions, practicing on graph, speed time graph. Everything stays the same. We know how we find the gradient,
Yes,
how we find the area. This time, what there's one additional thing. We did not find the area and distance time graph. Now,
yes,
for
sir.
speed time graph, the gradient will give us acceleration
Yes, sir.
and area under the graph will give us
Very
distance.
distance. Yes, sir.
I think
For
you would have seen
tripping.
that in physics
Yes,
as well.
yes, sir.
And this is the only difference in distance time and speed time graph, and every other concept stays same, the sketching,
Yes, sir.
calculations.
Yes, sir.
If I would just talk about this graph, I will say that the gradient is decreasing. That means the acceleration is decreasing, and ultimately the particle reaches its terminal velocity or the constant velocity. If I will explain the first one, I would say the particle accelerated at a constant rate, then the acceleration was zero, traveling with constant velocity. After 40 seconds, it started to decelerate at a constant rate. Let's just do the first question and then we'll end. On the graph of in this exercise, the vertical axis represents speed and the horizontal axis represent time. Find the acceleration between 0 and 10. So between 0 and 10, gradient will give me the acceleration. So this is 1.5 meters per second square. Then it says the total distance traveled. Total distance traveled is the area under the graph. And I can see the shape is trapezium. You may wish to split them up. You can do that. So trapezium is 1 by 2 into sum of parallel sides 60 plus 30 and times height. Height is 15. So 60 and 30 is 90. 90 times 15 is 1350 divided by 2 is 675. So it is 675 meters. Meters per second and second, yes. The last one says the average speed. So total distance over total time. 675 by 60. Total distance over total time is 11.25. Average speed meters per second. Okay. Do practice, do write on paper.